We are in the AI Builder platform and constructing a pipeline called Unify Flow. Our AI Builder leverages protobuf interfaces to enable adaptive, modular, and cognitive architectures. Leveraging these capabilities, the platform enables intelligent workflows through two key innovations: multi-agentic coordination and long-term memory. The pipeline here provides unified agentic workflows and memory systems to give contextual personalization and dynamic knowledge retrieval within a single intelligent workflow. This integration enables more adaptive and context-aware processes for the users. The pipeline here consists of 5 nodes, and each node is connected through their protobuf interfaces. The interfaces can be identified by hovering over the small icons around the node and connecting them to the other nodes. These protobuf interfaces are defined in the protobuf definition files. Here the main connections are send tool updates and prepare tool calls from MCP servers to tool interaction in the LLM node. Once the pipeline is constructed, they can be saved with a suitable name and version in the AI Builder. Clicking on the saving option, we can give or enter the solution name and a respective version number with which it can be identified in the AI Builder. Once the pipeline is saved, it can then be validated and deployed in the execution environment. This is called AI Runner, and an AI Runner serves as the execution and benchmarking platform for AI workflows across diverse environments such as Kubernetes, cloud services, or high-performance computing system. The nodes are now up and running, and we can also check the logs of the Neo4j to see if it has started. The DB port can then be used to access the Neo4j browser directly and visualize the graph data stored there. The Neo4j already consists of 95 nodes of data representing European countries and their important features. We will now run the pipeline and navigate to the web UI. The first question to the pipeline is to scrape a website for a specific data and key information. The LLM then fetches the schema or tool description from the connected MCP servers and use them to send the tool call request to the correct MCP server. Here, the MCP scraper tool gets picked up, which will scrape the entire website for the key information. The system is designed in such a way that the results will then be added to the knowledge graph. Now, when we pose the second question about the same website, the knowledge graph or the Neo4j database gets activated that will fetch information from this graph data instead of the tool calling function. We can then go back to the Neo4j browser to also verify if the tool message from the scraper tool is stored in the Neo4j. We can make use of the Cypher query or Cypher syntax to browse through the graph database. We can interact with the web UI and ask multiple questions such as regarding current weather or places or about some location, and the MCP tools will be made use of by the LLM. In this way, the LLM attempts to select appropriate tools or utilize the Neo4j database to retrieve answers. If neither the tools nor the Neo4j database are helpful, the LLM will answer the questions directly. That concludes the tutorial. Thank you for listening, and please feel free to try the pipeline on our AI Builder platform.